Dear students, these are chemical properties of P block element, in which first is oxidation state and trends in chemical reactivity. The common oxidation state of these elements are -3, +3 and +5. The tendency to exhibit -3 oxidation state decreases down the group due to increase in size and metallic character. In fact, last member of the group, bismuth, hardly forms any compound in -3 oxidation state. The stability of +5 oxidation state decreases down the group. The only well characterized bismuth 5 compound is BiF5. The stability of +5 oxidation state decreases and that of +3 oxidation state increases due to inert pair effect down the group. Beside +5 oxidation state, nitrogen exhibits +1, +2 and +4 oxidation state. Also, when it reacts with oxygen, however, it does not form compounds in 5 oxidation state with halogens, as nitrogen does not have d orbitals to accommodate electrons from other elements to form bonds. Phosphorus also show +1 and +4 oxidation state in some oxalic acids. In case of nitrogen, all oxidation state from +1 to +4 tend to disproportionate in acid solution. For example, HNO2 gives you HNO3 plus H2O plus 2NO. Similarly, in case of phosphorus, nearly all intermediate oxidation state disproportionate into +5 and -3 both in alkali and acids. However, +3 oxidation state in case of arsenic, antimony and bismuth becomes increasingly stable with respect to disproportionation. Nitrogen is restricted to a maximum covalency of 4, since only 4, that is 1s and 3p orbitals are available for bonding. The heavier elements have d orbitals in outermost shell, which can be used for bonding or covalency and hence expand their covalency, as in PF6. A very important topic: anomalous properties of nitrogen. Nitrogen differ from the rest of the members in this group due to its smaller size, high electronegativity, high ionization enthalpy, and non-availability of d orbitals. Nitrogen has unique ability to form p-pi multiple bonds with itself and with other elements, have small size and high electronegativity, that is carbon and oxygen. However, elements of this group do not form p-pi bond, as their atomic orbitals are so large and diffuse that they cannot have effective overlapping. Thus, nitrogen exists as diatomic molecule with a triple bond, one with S and two P between the two atoms. Consequently, its bond enthalpy is very high. It is 941.4 kilojoule per mole. On the contrary, phosphorus, arsenic, antimony form single bonds as PP, AS and SB, while bismuth form metallic bonds in element state. However, the single NN bond is weaker than the single PP bond because of high interelectronic repulsions of non-bonding electron owing to the small bond length. As a result, the catenation tendency is weaker in nitrogen. It is a very, very important question which is present in exercise also, give why the catenation tendency is weaker in nitrogen. So answer is here. Another factor which affect the chemistry of nitrogen is the absence of d orbital in its valence shell. It is again a very important point. Besides restricting its covalency to 4, nitrogen cannot form d-pi bond as the heavier elements can. That is R3p is double bond O, that is R3p double bond CH2R. R is an alkyl group. Phosphorus and arsenic can form d-pi bond along with transition metals when their compounds like PC2H5 will rise and AsC6H5 will rise act as a ligands. So these are the all about the oxidation state and trends in chemical reactivity. Chemical reactivity में सबसे पहले है बच्चों reactivity towards hydrogen. All the elements of group 15 form hydrides of the type EH3. आपको पता है +3 ऑक्सीडेशन स्टेट है तो EH3 टाइप के हाइड्राइड्स बनाएंगे वेयर E इज इक्वल टू कोई भी एलिमेंट हो सकता है नाइट्रोजन फास्फोरस आर्सेनिक एंटीमनी बिस्मिथ. सम ऑफ द प्रॉपर्टीज ऑफ दीज हाइड्राइड्स आर shown in table this. The hydrides show regular gradation in the properties. The stability of hydride decreases from ammonia to bismuth, which can be observed from their bond dissociation enthalpy. Consequently, the reducing character of hydride increases. Ammonia is only a mild reducing agent, while BH3 is the strongest reducing agent among all the hydrides. Basicity also decrease in order that ammonia is the highest, then phosphorus, then arsenic, then antimony, and then bismuth. Look, I have a table 7.2. Here are the properties of hydride of group 15 element, that is melting point, boiling point, EH bond distance, angle, and HF, all enthalpies. Second is reactivity towards oxygen. All these elements form two types of oxides, E2O3 or E2O5. The oxide in higher oxidation state of element is more acidic and then that of lower oxidation state. It is a very important point. Their acidic character decreases down the group. Remember, as we go down the group, their acidic character decreases. The oxide of the type E2O3 of nitrogen and phosphorus are purely acidic, that of arsenic and antimony amphoteric, and those of bismuth are predominantly basic. Next, थर्ड प्रॉपर्टी इज रिएक्टिविटी टुवर्ड्स हैलोजन. हैलोजन के साथ रिएक्ट करके फिर ये EX3 टाइप और EX5 टाइप हैलोजन्स बना रहे हैं. These elements react to form two series of halides, EX3 type or EX5 type. Nitrogen does not form pentahalides. Again, a very important question. Due to non-availability of d orbital in its valence shell, pentahalides are more covalent than trihalides. All the trihalides of these elements except those of nitrogen are stable. In case of nitrogen, only NF3 is known to be stable. Trihalides except BIF3 are predominantly covalent in nature. Next property is reactivity towards metals. All these metals react with metals to form their binary compound exhibiting -3 oxidation state such as Ca3N2, that is calcium nitride, Ca3P2 calcium phosphide, Na3As2 sodium arsenide, Zn3Sb2 zinc and antimonide, and Mg3Bi2 it is magnesium bismuthite. So these are the properties of chemical properties of p block elements.